Okay, let's do one more of the calculator problems. Cotangent inverse of -2. We do not have a cotangent inverse button on the calculator, so we're going to find a function that we do have that has the same region, which would be cosine inverse. Okay, now cotangent and cosine do not have a reciprocal relationship, so we're going to actually have to go over here, and the cotangent, your cotangent is going to be, we're going to recall cotangent theta is going to be your x over your y value. So we're either going to be in quadrant 1 or 2, but if it's a negative value, where does that put us? In quadrant 2. So our x value is a -2, and our y value is just going to be 1. So that's -2 over a known 1 right there. So x value, y value. Okay, when we put that in Pythagorean theorem, 1 squared plus 2 squared is, that'll be a 4, plus 1 is 5. So this is plus or minus the square root of 5. We've done that multiple times this lecture. Okay, now we want to redefine this in terms of cosine. So what would be our cosine value? It's our x over our, remind you, over here, cosine theta is going to be x over your r. So our x value is going to be -2. And what's our r? Our radius is square root of 5. So this is what we're ready to put in the calculator. Put cosine inverse, make sure you're doing the inverse. So it should get approximately 2.68. Okay, so that's just an extra example of that one. And then number 10, if tangent theta is 1/2, so it tells us what tangent theta is. It also gives us our region, which is the right side of the unit circle. Then what's the sine of theta? So what we're going to do first of all is we're going to say if the tangent, which is your sine over your cosine, that's your y over your x, is positive, then we know we are going to be in quadrant 1. Well, tangent theta, let's recall tangent theta is going to be what value? Your y value over your x value. So y value of a 1, x value of a 2. What happens when we have sides of 1 and 2? We get square root of 5 using Pythagorean theorem. Okay, now what is the sine of theta given down here? By definition, sine of theta is going to be your y value over your radius. In our particular case, what is that going to be? 1 over square root of 5. Now, what about this? It's not simplified algebraically, so let's just rationalize the denominator by multiplying by the square root of 5 over square root of 5, which would just give us square root of 5 over 5. This is just a different presentation in which these kind of questions may be asked. Okay, I'm going to take you back to the presentation that was given in this manner. So remember, we would start with this inside first, and we would say, well, we're trying to figure out what theta is, so we'll say, well, let's let theta be that sine inverse of square root of 3 over 2. Okay, now we're going to be able to undo this inverse, we're going to use our property and multiply both sides by the sine. Whatever you do to one side, do to the other. And then this gives us our property. Sine times the sine inverse is just going to be our x value. So then we would just say sine of theta is equal to the square root of 3 over 2. And recall, sine is defined by the y value over the r. We got to go find out where that is. So it's going to be sine inverse is going to be the right side of this, so we're either in quadrant 1 or here. It's both positive, so that means we're going to be in quadrant 1. The y value is the square root of 3. The x value, the radius is a 2. Now we'll have Pythagorean theorem to find out our missing side, so we'll let a be the square root of 3. Side B, we don't know. C is the hypotenuse. It's always the longest side, or the radius in this case. So the square root of a number squared would just be the number. Okay, and we're subtracting 3 from each side, so we get b squared is equal to 1, and we take the square root. So you're going to get b is plus or minus, the square root of 1 is just 1. So in this case, it's a positive 1. Okay, with all that being done, we remember we're looking for the cosine of theta. So what is the cosine of theta at that position? We said cosine of theta is defined by your x over your r. So what is our x value? 1. And what is our r value? 2. So the answer to this is 1/2. Okay, I want you to try this one all the way through. Take a few minutes to write it down and then pause it and see how far you can get on this. I'm just going to show you the solution. Okay, the first thing is that we're just going to use our property to find cosine of theta equals negative 1/2. Okay, so that means cosine's up here in the top half. This is a negative value, so we're over here in quadrant 2. X is negative 1. Radius is 2. Use Pythagorean theorem to solve for the missing side, but it's similar to this previous one, a radius 2 and a side of 1. The other side is square root of 3, so you can either use your previous examples work, or which that's not the same work, but a squared plus b squared equals c squared. Just so that you see it, you have negative 1 squared plus or minus the square root of 3, and of course that one's a positive square root of 3. And then we'll recall that keep in mind we're looking for the tangent theta, which is defined by y over your x. So tangent theta is equal to the y value is, what's our y value? Square root of 3. What's our x value? Negative 1, so it's just going to be negative square root of 3. Okay. Okay, this one's a little bit different. This time we have the sine inverse on the outside and just cosine of 7 pi fourths on the inside. We're going to do order of operations first. We're still going to work with this inside first, but this is just a basic. What is the cosine at 7 pi fourths? Go to our unit circle, 7 pi fourths. What's our cosine value there, which is the x value? Square root of 2 over 2. Good. So basically I rewrite this problem, substitute cosine of 7 pi over 4 with square root of 2 over 2. And now we are looking in our inverse region, which if we were to highlight it, where's that going to be? The right side. So I'll take a few seconds to highlight the right side. And what angle theta gives us the sine value of square root of 2 over 2? Positive square root of 2 over 2. Right here, the y value. So our answer to this is just going to be pi fourths. Okay, we have a couple of options with this. We worked this problem in a calculator earlier, but let's just not use a calculator this time. What if I did secant inverse of 2? First of all, my secant has a similar region as cosine except for at this restriction here. But I'm going to use the same concept. I'm going to rewrite that just because it's easy to work with cosine and sines. Cosine inverse, what's the equivalent to this? If this is a 2, what's the reciprocal? 1/2. Well, this is a lot easier for me. Go find the angle theta in which the cosine value is 1/2. So where would that be? Because it's in the same region. Where is the cosine? Positive 1/2. Pi over 3. So you can apply that same idea and concept without using the calculators. Well, Now what about this one? If I seek an inverse of 8, if I used rewrote it as cosine inverse, what's that become? 1 over 8. Now is 1 over 8 anything over there? No, so that's definitely one that's easier to do in a calculator. Okay, so where this particular one was real easy to do in a calculator, this particular one's probably quicker for me to just look at my unit circle and pull an answer. So you can see how you can be versatile there. And let's go ahead and get a value that's approximately 1.44. So unless it tells you a specific way, you're free to use either method. I wanted you to see each option. So that's a wrap.